this is Swathi. So I'm here to discuss with ionization energy. As in the previous videos we discussed about valency and atomic radius. Now we are going to discuss about the third property, that is ionization energy. So ionization energy, this is also called as ionization enthalpy. Enthalpy is nothing but energy. This we can write it as IE, ionization energy. So in the definition, what is the definition of ionization energy? So that means here only is there ions, atom converts to ion. So the amount of energy, ionization energy is defined as the amount of energy required to remove the electron from the isolated gaseous neutral atom. Ionization energy is defined as the amount of energy required to remove the electron from isolated gaseous neutral atom. So here different terms are there: isolated, gaseous, neutral atom. Isolated means generally you know that, so whether it's a solid or liquid or gases, between one atom to another atom there will be a force of attraction. So we need to break down all the force of attractions and we need to get the single atom. So mostly individual atoms are available in the gaseous phase. That's why isolated, gaseous. So isolated means separated. That compound should be in gaseous phase, and neutral. We have to remove the electron from neutral. When the atom neutral, when it is in atomic state only, it's neutral. If it lost or gain the electron, it becomes the ion. So neutral means it is the meaning of atom. Isolated, gaseous, neutral atom. So we know that here electrons are present in the extranuclear shell and protons are present at the center of the atom, is called nucleus. So between these positively charged nucleus and negatively charged electron, there will be always attractive forces. So we need to break these attractive forces and we need to remove the electron. We know that to break anything, we need certain amount of energy. So here also, to remove or to take it out this electron from these attractive forces of nucleus, we need certain amount of energy. That amount of energy which is required to remove the electron from neutral atom, that energy we call as the ionization energy. So we take to break anything, so energy is taken out from our body to break. Here also, to break this one, we need to give the energy from the outer source as in the form of heat or light. Then it is a absorbed amount of energy, absorption energy, that is endothermic or exothermic. So it is the endothermic, absorption of energy. So ionization energy is endothermic. The next, so if you consider an atom, how many ionization energies are possible? So always the number of ionization energies for a given atom always equal to its number of electrons. Like if you take the helium, it has only 2 electrons. It nothing but it has 2 ionization energies. If you come to the oxygen, it has atomic number 8. It means it has 8 electrons. Then it has the 8 ionization energies. Like if you come to the fluorine, it has 9 electrons. It has the ionization energies 9. So every atom have the number of ionization energies is equal to its atomic number or the number of electrons. Then, so the first, if you take metal, general M refers for metal. So I am removing the first electron from the metal. Then by the removal of 1 electron, it becomes as M plus and it lost 1 electron. This we call as first IE, first ionization energy. Then this we call as, by the loss of 1 electron, what is the ion resultant? That we call as unipositive ion. Unipositive ion. So the amount of energy required to remove the electron from the unipositive ion to form a di-positive ion that we call as second ionization energy. Always second ionization energy is greater than the first ionization energy. That is only due to the increase in nuclear charge. Increase in nuclear charge. Then how it changes in groups and periods. So first in case of groups. So when we come to the groups, so the first general we'll discuss first group, that hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So when we come to the down to the group, as atomic size increases, then ionization energy decreases. Ionization energy decreases. Then when we come to the period, so like second period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So when we come to the left to right, its atomic size decreases. Its atomic size decreases. Due to decrease in size, its ionization energy increases. Its ionization energy increases. Then this is the order of ionization energy. But here some exception is there. Then when we come to their electronic configuration, it is 2s1, 2s2, 2s2, 2p1, 2s2, 2p2, 2s2, 2p3, 2s2, 2p4, 2s2, 2p5, 2s2, 2p6. Then if you come to here beryllium and nitrogen, as we learned in structure of atom, atoms with either off-filled or completely filled electronic configuration, they are more stable. So here beryllium has the completely filled s orbital and nitrogen have the off-filled p orbitals. Due to that, they are having some exceptional electronic configuration, electronic ionization energies. So here in the group, in this period, beryllium has more ionization energy than boron. Even nitrogen has the more ionization energy than oxygen. This is the exception in case of periods. So generally when we come left to right, ionization energy values increases due to decrease in the size. Then beryllium and nitrogen. Beryllium has completely filled s orbitals and nitrogen having the off-filled p orbitals. So either any atom or ion having the off-filled or completely filled atomic orbitals, they have the extra stability. Due to this extra stability, it is difficult to remove the electrons from beryllium and nitrogen. So beryllium having a little more ionization energy than boron, and nitrogen has the more ionization energy than oxygen. So what is ionization energy? Energy required to remove the electron from isolated gaseous neutral atom. Then units non-ionization energy is measured in electron volts. Group. So in a group, top to bottom ionization energy decreases as a result of increase in atomic radius. Then in a period, left to right, ionization energy increases. Ionization energy value increases due to decrease in the atomic radius. So here beryllium and nitrogen are having the exceptional ionization energy. So in the some books is also given as it's not following regular trends because of this beryllium and nitrogen. So beryllium has having the completely filled s orbital, nitrogen having the off filled p orbitals. Due to this, they have the extra stability. To remove the electrons from the extra stable atoms, we require the much energy. That's why beryllium has more energy than boron and nitrogen having more ionization energy than nitrogen. So in case of in general, we'll speak in a period left to right, ionization energy increases, or we can say it's not following regular trends. What is the reason? Means beryllium and nitrogen have the off-filled and completely filled orbitals. Thank you friends. I hope all of you understand. We will meet again in the another video.